All right, let's look at worksheet 7.5, problem number 1. And the question or the directions say use Taylor's theorem to determine the error bounds of the approximation. And the problem says E is approximately 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial. And I actually think this problem is better understood if we look at a Taylor polynomial, because I think the Taylor polynomial will help us explain what it is we're looking for. So we know that e to the x is the sum from n equals 0 to infinity of x to the n over n factorial. What we're finding, although it's not written, is e to the 1, right? We just don't write it, but we understand that the exponent up here is 1. So e to the 1, using a Taylor polynomial, would be 1 raised to the n over n factorial. And so then you can see where those terms come from, the 1, the 1, the 1 over 2 factorial. Because if we let n equal 0, we would get 1 to the 0, which is 1, over 0 factorial, which is just 1, plus, if we let n equal 2, n equal 1, we get 1 to the 1 over 1 factorial, which is just 1. And if we let n equal 2, we get 1 over 2 factorial, and you can see the pattern that's happening here. Okay, so there's a couple things that this clues us in on. One, this is a 4th degree Taylor polynomial. And the 4th degree polynomial happens to be centered at x equals 0 with an x value of 1. So we can see this Taylor polynomial. Now, tell me what that means. If we are dealing with a 4th degree polynomial, we know e to the 1 is actually equal to the polynomial approximation at 4 plus the remainder at 4 of that polynomial. Okay, so what we have up here, what these terms are right here, represents that 4th degree polynomial. So we know that the remainder that we want, according to Taylor's theorem, our remainder for this needs to be less than or equal to f, the 5th derivative, because it's 1 more than the polynomial, evaluated at some point, we'll talk about what that means, times x minus the center, but my center is 0, so x to the 5th over 5 factorial. Okay, so what we talked about before was that this expression right here, this expression, remember, stands for the max derivative, or the max value of the derivative. Let's erase that. Let's call that the max value of the derivative. Max value of the derivative of the function. And in this case, it'd be the function, the 5th derivative. Well, tell me what we know our function is. Well, our function is this e to the x. So the 5th derivative, I don't even have to go through all the iterations of the derivative because we know the 5th derivative is e to the x. Now, the key to this is the interval, because the max derivative of e could be a lot of things. So it's all based on the interval. So our interval is what? Well, remember we said if we don't know our interval, then the interval has to go from the center to the point, or from the point to the center, depending on which order it is. But in our case, our center is 0, and our point that we're concerned about is 1. So if we think about the derivative of e to the x evaluated from any point, that's the a value. A is somewhere in this interval from 0 to 1. It can be 0, it can be 1, it could be somewhere in between. What number from 0 to 1 gives me the highest derivative? Well, 1 would. And we know then that this f sub 5 of a happens when we have e to the 1st power, because that would be the highest number. Now, e to the 1st is just e. So we could certainly use e if you wanted, or something just bigger than e, something that's reasonable by e. So we could even use 3 if you wanted. So this max derivative would be 3. So what we're going to fill in is we're finding the remainder at the center, or at the point rather, which is 1. And it's going to be the absolute value of that max derivative, which we can call it e, we can call it e or 3. And then this will be x to the 5th, but we know what x is. It'd be 1 to the 5th over 5 factorial, and it'd be the absolute value of this. And so if we plug this into a calculator, 3 over 5 factorial is 120. So if we did 3 over 120, you could certainly do it that way, which would leave you with 1 over 40. But this would be 1 over 40, roughly speaking. And I know my remainder cannot be more than that. And I just used 3 instead of e at that moment. But you could certainly leave it or as e over 5 factorial as well would be acceptable. So we know that that error has to fall within a range that is less than or equal to the absolute value of 1/40th or the absolute value of e over 5 factorial.